Hello all, Mr. Callen here to help you with Chapter 3, Lesson 7. More on two-step equations. Remember where we have been in red down below where the hot air balloon starts. We've been talking about one-step equations for a while. Then we moved into some two-step equations. It's time to do a little more. You're looking at those equations. You might know the difference. That's where we are heading because sooner or later we'll get to multi-step. But first, let's really get those two-step equations down. And let's proceed that with some assignment checking. If you've already checked these, great. If not, I'd like to offer that to you again. This is assignment 22, page 75. Go ahead and pause and come back when you are ready. So go ahead and now title your new page for this. I'll give you a few examples. This is assignment number 23. I'm going to lower the number of problems slightly. Page 77. Let's do 6 through 21. Pause and come on back when you're ready. So we were briefly talking about this in class the other day, and I'm getting a worried feeling in my stomach, a little feeling that says, do these students really understand the concept of equation, or are they just doing whatever the teacher does because the teacher says to do it? So I want you to be able to draw it out if at all possible. I'm not going to tell you to do that tonight, but I can feel that coming for some kind of quiz problem. You should be able to see, all right, so pretend these are envelopes of money at the top. We got 3 envelopes of money. We don't know how much those are, so we'll give those a random variable. We'll call it X. We have another $7. Instead of drawing dollar bills, I drew 7 pluses. And if you put all those 3 envelopes of money with some missing amount, plus the $7, it's equal or identical to the 22. Now you realize the first thing we want to get rid of is the 7. The question is why? Well, think about this. If we want to know what each of these envelopes is by themselves, speaking of by themselves, let's get rid of that 7. So we're going to take away 7, and of course, we must be fair to both sides. So we're going to get rid of 7 over here. That, ladies and gents, is why we are left with 3 envelopes of money and $15. Beyond that, the next piece of this puzzle is I don't want to know what 3 envelopes of money are worth. I want to know what a single envelope of money is worth. Now, at this point, you're saying, well, the teacher said the opposite of multiplying is to divide. But I want you to ask yourself, why are we dividing? For this, again, take a look at your picture. Ultimately, you want to know is, what's up with these dollar bills and how many goes in each envelope? Well, that, ladies and gents, is why we divide. We're going to split up or divide whatever is remaining fairly into each envelope. When you do that, please notice that if you split 3 envelopes into 3 parts, you get a single envelope. The 3's will cancel out. If you split $15 into 3 parts, you will see that each envelope is full of $5. And of course, we could go on and check that. You could even check it pictorially by drawing $5 bills or 5 plus symbols in each and adding the 7. And if you have 5, 10, 15 plus 7 is 22, you will notice that they are fair. Okay, now let's go on to something that I think is a bit more challenging to understand conceptually. When you look at this, that is not 1 envelope of money. It is not multiple envelopes of money. In fact, some people would prefer to write this as a third of an envelope. In other words, we're taking one big envelope and we're splitting it up into 3 parts, and we're saying all we have is 1/3 of that. So, not the prettiest picture, but that's what I really want you to understand for now. We'll get back to that. Interestingly enough, our first goal still, if we want to know the envelope, is still to get rid of that $7. We call that the constant term. 7 does not have a variable, it has a constant. And so what does that leave us with? Well, on the left side, all that's left is that third of an envelope of money. On the right side, we got 15. Now be careful here, because you will be tempted to say, oh, Mr. Callen, I got this. Go ahead and just divide it up again, and then we'll be good. No, 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 no. Think about what this means. We have a third of an envelope of money is $15. But again, we don't want to know what a third of it is. We want to know what an entire piece is. And speaking of pieces, just picture it. If that third is 15, then so is that third. If this third is 15, then so is that third. In other words, what are we going to do here? Well, it's going to take 3/3, boom, boom. 3/3 gives me one whole envelope. And naturally, 3/15s will give me the $45 that I envisioned. So I don't want you just to do whatever the teacher says. Well, the opposite of divide is multiply. No, 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 no. Understand what we're talking about. So picture whether it's envelopes of money, whether it's quantities of time that you're playing video games. Are you playing for 1 hour? Are you playing for more than an hour? Are you playing for a part of an hour? In the top case, we have 3 envelopes of money. In the bottom case, we have a part of an envelope. In both cases, we get rid of the extra constant term by eliminating the 7. Then we eliminate the coefficient, but when you have multiple envelopes, you'll divide and split it up. When you have a part of an envelope, you will multiply to get one whole envelope. So please keep that conceptual understanding of what an equation means in your mind as we go through these couple examples. If you need to pause, rewind, go about your business, that's fine. Let's go ahead and do example 1. And again, when I look at this, I'm kind of picturing it in my head. Okay, I have a part of an envelope of money. I got a piece. But meanwhile, then somebody took away $3. I want to know what happened before they took away that $3. So let's go ahead and add that $3 back in. Why do we do that? Because $3 minus $3, good. Before anybody took away money, I had a portion of an envelope, which was $4. But again, I want to know what the entire envelope is. So to find out what the entire envelope will be, I'm going to go ahead and multiply by 8. Now think about what just happened. We multiply by 8 because 8/8 of an envelope is, you guessed it, one whole envelope. And yes, you do not need to write it out. Meanwhile, 8 groups of $4 gets me to 32. Or does it? You know what's coming. We're going to get to the check part. So let's go ahead and rewrite that equation. Some missing amount split up 8 times, then $3 taken away. But now we think we know what that missing amount is. So let's go ahead and check it. 32 divided by 8 is 4. 4 take away 3. No fake checking, ladies and gentlemen. Really do the computation. And if that means for a moment you have to cover up that right side and do the left side and then say, okay, is that in fact a true equation, a true statement? In this case, of course it is. Now I'm going to go ahead and ask you to pause. Look at number 1, look at number 2. How are they similar? How are they different? I'd like you to solve number 2 and come on back when you're ready to check it. Now you see different pieces. Obviously the C is on the right side. That's okay. We're dividing by 5 instead of dividing by 8. We're adding 4 instead of subtracting 3, but that's okay. We're still going to get rid of that constant term first. So the first thing we'll do is subtract 4 from both sides. So that leaves us with a part of an envelope is $10, but we don't want to know what the part of the envelope is. On the left problem, we go ahead and multiply both sides by 8 to get the full B. On the right problem, we'll multiply both sides by 5 to get the full B. And when you check it, 50 divided by 5 is 10, and 10 plus 4 is in fact 14. So it checks out. Pause if you need. Rewind if you need. Let's keep on rolling. Okay, this kind of looks familiar. Okay, all right. So in this case, we don't have a part of an envelope. We have multiple envelopes, but still someone took away that $2. So what are we going to do? We're going to add that $2 back in as long as we're fair to both sides. Now, before someone took away that $2, we had 12 envelopes of money equaling 24. But we don't want to know what 12 envelopes of money is, so let's go ahead and split up both sides into 12 parts. When we do this, 12 twelfths naturally makes one whole, and 24 split into 12 envelopes means there was $2 in each, or was there? Let's go ahead and rewrite the equation, 12 times some missing amount, but now we think we know what that missing amount is. So let's take the 2, substitute it in, and find out. In this case, 12 times 2, 24. 24 take away 2 is 22. Is that a true statement? Well, yes, indeed, ladies and gents, it is true. All right, now take a look at number 4, my example number 4. How are they similar? How are they different? Pause if you need. Go ahead and do this on your own and come on back when you're ready. You may have guessed, I'm going to leave the 8t's on the right. I'm very aware that some of you take that equation and move it around. So long as everything is not changed or altered in its sign, you are keeping that equation fair and balanced, that's okay. As for me, I'll leave the t's on the right, and I'm going to eliminate the 9 first. Once you eliminate the 9, then go ahead and find out we have 8t's equal 32, but we want to know what a single t is. So let's divide both sides by 8. In this case, we believe it's 4. And when we check, it ends up working out. 8 fours is 32. 32 plus 9 is 41. Indeed, that is a true statement. That's what I have for you, folks. Go ahead at this time, draw a line underneath any examples that you just wrote. Don't forget the directions, whatever the directions are. I think it might be just solve and check. When you get to problems in 19, 20, 21, really focus on how to turn those verbal sentences into mathematical sentences. You're going to take the words and rewrite it in math, numbers, symbols, variables, etc. All right, do well, folks, and let's grow.